India, with its vast borders and complex security challenges, has always sought a watchful eye in the sky. The Tapas drone, also known as the Medium Altitude Long Endurance or MALE Unmanned Aerial Vehicle, was envisioned as the answer. It promised persistent surveillance capabilities, bolstering India's defense posture. The Tapas drone was designed to be a game-changer, providing real-time intelligence, surveillance, and reconnaissance data for both military and civilian applications. The anticipation for the Tapas drone was palpable. It was designed to carry a variety of payloads, including synthetic aperture radar, electro-optical sensors, and electronic intelligence systems. These capabilities, it was hoped, would provide India with a critical edge in monitoring its borders, tracking hostile activities, and responding effectively to emerging threats. The development of the Tapas drone, however, has been plagued by numerous technical challenges. One persistent issue has been achieving and maintaining stable flight, particularly at high altitudes. This is crucial for a drone that's meant to stay airborne for extended periods, covering vast distances. Another hurdle has been the seamless integration of various sensors and payloads. Ensuring that these sophisticated systems communicate effectively and provide accurate data in real time has proven to be a complex undertaking. These technical complexities have resulted in significant delays in the Tapas program. The initial optimism surrounding the drone's development gradually gave way to concerns as deadlines were missed and the project's timeline stretched further into the future. These delays have not only impacted India's immediate defense preparedness, but have also raised questions about the country's ability to deliver on ambitious indigenous defense projects. Another major obstacle faced by the Tapas project has been funding. Developing advanced military technology, especially a complex system like a MALE UAV, requires substantial financial investments. However, the Tapas program has often found itself competing for resources with other defense priorities. This has led to budgetary constraints, which have, in turn, impacted the pace of development and procurement. The lack of consistent funding has created a vicious cycle. Delays caused by funding shortfalls have resulted in increased overall project costs, further straining the limited budget allocated to the program. This has made it challenging to acquire the necessary components, conduct comprehensive testing, and ultimately field the Tapas drone in a timely and effective manner. Section 4. Chains of Dependence. Relying on foreign tech. India's aspirations to become self-reliant in defense technology have faced a reality check with the Tapas project. Despite efforts to indigenize the drone's components, there remains a significant dependence on foreign technology. This dependence is particularly evident in critical areas such as engines, sensors, and flight control systems. Relying on foreign suppliers for crucial components has several drawbacks. Firstly, it makes the Tapas program vulnerable to geopolitical factors and potential supply chain disruptions. Secondly, it hinders India's quest for technological autonomy in the defense sector. Dependence on foreign technology also limits India's ability to customize and upgrade the drone's capabilities independently. Section 5. The Gauntlet of Testing. Proving grounds and paper trails. Before any military hardware can be deployed operationally, it must undergo rigorous testing and certification processes. This is particularly true for unmanned aerial vehicles like the Tapas, which are expected to operate in complex and often hostile environments. The testing phase for the Tapas drone has been extensive, involving countless hours of flight tests, simulations, and evaluations. While these tests are essential to ensure the drone's reliability, safety, and effectiveness, they are also time-consuming and add to the overall project timeline. Moreover, the certification process, which involves meeting stringent regulatory standards and obtaining necessary clearances, can be a lengthy and bureaucratic process, further delaying the Tapas drone's entry into service. Section 6. A Hope for the Future. Lessons from Tapas. The journey of the Tapas drone, though fraught with challenges, offers valuable lessons for India's quest for self-reliance in defense technology. Firstly, it highlights the critical importance of consistent funding and streamlined procurement processes. Secondly, it underscores the need to reduce dependence on foreign technology and accelerate efforts to develop indigenous capabilities. The Tapas program also demonstrates the significance of realistic project timelines and a focus on addressing technical challenges early on. By learning from the setbacks and incorporating these lessons into future defense projects, India can pave the way for a more robust and self-reliant defense industrial base. The dream of a made-in-India male UAV is still very much alive, and the Tapas drone, despite its challenges, has played a crucial role in shaping that dream.